Okay, so let's give you guys another random integration question. So somehow integrate this from 0 to a half. So press pause and have a go. Okay, so to do this, when you're integrating, always try to keep a lookout for something being the exact derivative of another thing. So if you look at this bit here, this here is pretty much the exact derivative of this thing here. Because when you differentiate this bit here, it would when you differentiate this bit here, it will give you minus 2x. And then here you've got an x here you've got an x. So try to keep an eye out for something being the exact derivative of another thing. So this here is pretty much the exact derivative of this. So what you currently have here, imagine this thing here as this. Currently what you've got is 1 minus x squared. Well, square root is a half, and because it's 1 over that square root, in a way it's like this, 1 over the square root of blah blah. So you stick a minus in here. So currently, I know there's an x here, but let's forget about this x for the time being. So currently what you've got here is pretty much this thing here. Now if I were to ask you to integrate this, then you would look at this and you would need one notch higher than this thing here. So what you would need, so currently, what you've got is this. Now if you want to integrate it, your initial guess would be one notch higher than the negative a half. So one notch higher would be this. Now if you were to differentiate this, it would then give you a half. Then the bubble stays intact, and then this thing here gets minus by 1, and then you've got to times with the derivative of the bubble itself. You've got to times with the derivative of the bubble itself, which would be negative 2x, and then this half will cancel out with this, and then you've just got a negative x here, and this x here will match up with the hang on. And this x here will match up with this x here. The point I'm trying to make is that if you're trying to integrate this, because you know that this is the exact derivative of this, then you should make this to be your initial guess. Make this to be your initial guess. When you differentiate it, it will give you this thing here, which is exactly the same as this thing here. The only thing that's different is this negative here. So you will need to make the adjustment. So make this to be your initial guess. So you see, if you integrate this, it will give you this thing here. So if you integrate this, it will give you this. It will give you this thing here. Okay, so because this is a definite integral, we will need to do it from 0 to a half. The point I'm trying to make here is that rather than using substitution, you can just keep an eye out for something being the exact derivative of another thing. So looking at this here, currently what you've got here is something similar to this, square root of 1 minus x squared. Well, that's pretty much this, to the power of negative a half. Hang on. So if you want to try and integrate this, you would need one notch higher than this, which will be 1 minus x squared, and then one notch higher than this would be a half. So make this to be your initial guess. When you differentiate this, it will give you a half, and blah blah. The bubble stays intact. Well, you can integrate this straight away without having to use substitution. So if you integrate this straight away, it will give you this. Now evaluate it from 0 to a half. So it will be this. Now it will be well, put this into here. So it will be this, which is this bit here. Take away this thing here, which happens to be a negative 1. Negative and a negative gives you a plus. Overall, the answer would be this. And by the way, you can use trigonometric substitution as well. You can use trigonometric substitution to evaluate the very same thing. So to use trigonometric substitution, your eyes should zoom into this bit here. It will still give you the same answer. Create your triangle in such a way that this will be true. If you make this to be, if you make the hypotenuse to be 1, the opposite to be to be x, then sine would be opposite over adjacent, which is just opposite. So hang on, I forgot something. So this here is theta. Okay. Well, use trigonometric substitution, and you can still evaluate this. It will still give you the same answer. And cosine is this thing here. So cosine will be this, and then now you can put this into here. Put the cos into this complicated square root thing here, and then the dx here is this thing here. So you can put it into here, and then this whole thing here will become this, and then cancel it out. Blah blah. We've done this many times, so now it's just a matter of integrating sine theta. Integrate sine theta, it will give you this. Now we need to translate back to. We don't want it in terms of theta. So we would look at this. What is cos theta? Cos theta is this thing here. It's this thing divided by 1, which is this thing here. So we can put it in here. The other thing that I forgot to mention is this. We were trying to integrate this from 0 to a half. When we made this substitution here, we were trying to integrate this. When we made this substitution, it took us into the d theta. So here we are dx from 0 to a half. Now, because we made the substitution, we are now in the d theta realm. By right, we should make the adjustments here. I forgot to mention that we should make the adjustment here, but don't worry about it, because right at the end we're going to translate everything back into the dx realm. So we don't need to worry about making the adjustment. Okay, so anyway, integrate this, use trigonometric substitution, it will take you to this. These two will cancel out, giving you this. Integrate this, it will then give you this thing here. But we don't want the answer in terms of theta, so we need to turn everything back into the x, in terms of x. So now, if you look at this, cos theta is this, so we can put this into cos theta. So that will then give you this. So when you integrate it, it will give you this. But then we were trying to evaluate it from 0 to a half. Remember this thing? From 0 to a half, blah blah dx, a half here. So because we're trying to evaluate a definite interval, then that will then take us to this. Evaluate that, it will then give you the same answer as above. Okay, but when you try and do this, when you try and do this, try to do it straight away without using. When you try and integrate this, try to do it straight away without using substitution. Just know that this here is pretty much the exact derivative of this thing here. So integrate it straight away. Okay.